Hello everyone, welcome back. Today we'll continue with the trigonometric functions. Alright, here if you have doubt like what is unit circle, in which quadrant sine theta is positive, in which quadrant cos theta is positive, right? Which are the value, uh, which are the domain and range for the trigonometric functions. So we are going to learn all of this, right? So watch this video till end. Right now let's start with some basics which you already know. So trigonometric ratio, it is a right angle triangle. This is the reference angle theta. Now base, perpendicular and hypotenuse. Now what can I say about this? Sine theta is nothing but perpendicular to hypotenuse. This you already know. Now I'll just show you the trick how to remember this. So sum p curly brown hair. Now how to understand this? So S for sine, P perpendicular, hypotenuse. So sine theta is perpendicular to hypotenuse. Cos theta, B is base and hypotenuse. So once you remember sine theta and cos theta, automatically you can understand the remaining ratios. So it is very easy to understand. Right? Now let's understand the unit circle. So a unit circle is nothing but the circle with the unit radius, right? Now here if you see, these are the points on the unit circle, right? You already know the coordinate geometry. So these are the points. Now the radius is 1 here. Now when I talk about this distance OM, so I have taken this as A, this as B. Now this angle is the reference angle x. So what I can say, sine x is nothing but b over 1, which is b, right? Then cos x is equals to adjacent base to hypotenuse. So I'll get a for this. Now we already know that uh, sine square x plus cos square x is 1. So I can apply the Pythagoras and I can verify this. So basically A and B. So the point P, coordinates are A, B, and I can give this as cos x sin x. So remember this is cos comma sine. Okay. Now you already know the coordinate geometry, right? The first quadrant, all values, I mean both x and y positive, right? X is positive, y is positive in the first quadrant. So in the first quadrant, cos is positive, sine is also positive. All right. So all trigonometric ratios are positive. All right. Then second quadrant, I know that x is negative, y is positive, right? So here if I'll consider sine and cos. So cos is negative and y means sine is positive. So sine and cosec theta are positive. Alright. Third quadrant, sine x and y both are negative. So sine and cos both are negative. When sine and cos both are negative, then tan theta and cot theta are positive. So very important. Alright. Then fourth quadrant, we know that x is positive, y is negative, right? So cos is positive and sec is positive, right? The remaining ratios are negative. So very easy to understand this, and you can use this ASTC rule. Now what does it means? All are positive here, right? Here sine and cosec are positive. Then tan and cot are positive here. So T and C is cos and sec, right? So ASTC rule, you can remember this with after school to college. Alright. Okay. Now some quadrantal angles and related trigonometric functions. So when all angles are integral multiple of pi by 2 are called the quadrantal angles. Okay. Now if theta increases or decreases by any integral multiple of 2 pi, then sine and cosine functions do not change their value. So here sine, when sine 2 and pi plus theta form, right? We are considering that. N belongs to z. So if I start with 0, so sine theta, sine 2 times 0 times pi. So I'll get sine theta only for this. Same way, if I substitute any value, I'll get the multiple of sine. Correct? Same way here, I'll get the multiple of cos, and that remains same. That won't change. So here also I'll get the cos theta value only. Alright. How this is, I'll explain you in further slides. So just be patient. Alright. Now, if theta is the integral multiple of pi, means what? 0 plus or minus pi plus or minus 2 pi and all, then sine theta is 0. Right. So see what does it says when I have this circle. Alright. So this is 0, this is pi by 2, this is pi, and this is 3 pi by 2, or 0, 90 degree, 180 degree, or and 270 degree and 360, right? So for this and this, sine is 0. Here cos is 0, right? Pi by 2, 90 degree. You already learned that. So they are just talking about everything, but in terms of radians now, pi value. Alright. So for 0, pi, 2 pi, right? Positive or negative, any. So sin theta is 0. Same way for odd multiples of pi by 2, cos theta is 0. So cos theta is, for 90 degree, 270 degree and so on, all multiples of 90. So cos theta is 0. The same way. Alright. So basically you can say that sin theta is 0 for theta and pi. Okay. N is any integer value. And cos theta is 0 for theta 2n plus 1 pi by 2, where n is again an integer value. Alright. Perfect. So to define cosec theta, the denominator should not be 0. So we have to exclude this value where x or theta, right? That becomes 0. So we have excluded those values over here. Correct? Alright. Now trigonometric identities, which you already learned ago also, right? So we know that sin square theta plus cos square theta is 1, 1 plus tan square theta is sec square theta, 1 plus cot square theta is cosec square theta. So please remember this. Alright. Now domain and range of the trigonometric function. So domain is nothing but any possible value where you can give as an input, right, to get the output. So domain, and range is nothing but the all values which are coming as the output. So that is nothing but the range. Alright. So for sin theta, domain is any real value. Range is always -1 to 1. Now close bracket means what? Including -1 to 1 any value. Any value. So if you see here 1 to -1. So that contains any value. So this is the graph. And sin 0 is 0. So we know that passes through 0. Then sin pi is 0. So and sin pi by 2 is 1. So this is how it changes, right? Same way cos theta, real value is the domain. Again that can take any value between -1 to 1. Now here if you see this is nothing but cos 0. So cos 0 is 1. Cos pi by 2 is 0. So this is how the graphs. These are for the negative value. Okay. These are for the negative value. Cos pi is -1. So this is here. So you can say this, right? Alright. Perfect. So this is how the graphs of sine and cos. Now tan theta. So domain. Now all real values. But that cannot take, see cos, tan theta is what? Sin theta upon cos theta, right? So when cos theta is 0, we have to exclude those values. So we have excluded the values of pi by 2 multiple, theta pi by 2 multiple, right? So range is any real number, okay? So this is how the graphs looks like. Alright. Now same way for cot theta. So we have excluded the values in domain where the theta value is 0. So this is how the graphs look like. Alright. Now same way for cosec theta and sec theta. So domain we have to exclude the values of theta where it becomes 0. Right. So we have excluded those values. Alright. And range. Now important thing is here is any real value just accept -1 to 1 excluded. Okay. So this is very important. So cosec theta can be 1. Okay. Can be 1 but cannot be between 0 to -1 or between 0 to +1. Alright. Just remember that. So if you see here these values are excluded. Right. So this cannot be. Same way for sec. These are excluded over here. Alright. So very important thing. These are for range. Alright. So just try to understand. Alright. You have to understand the graph, and by just looking on the graph you can understand, okay, this is for cosec theta or this is for sec theta or sin theta and so on. Alright. Now behavior of trigonometric function. So if you see here, again let me just explain you with this unit circle. Very easy to understand. Now 0, pi by 2, pi, 3 pi by 2, or I can say 0, 90 degree, 180 degree, 270 and 360. Right. Now cos 0 is 1, correct? Sin 0 is 0, sin 90 is 1. So in first quadrant sin is increasing. So increases from 0 to 1, correct? Now second quadrant sin. So here sin 90 is 1, right? Sin 180 is 0. So in second quadrant it is decreasing from 1 to 0. Now third quadrant, this is 0. Sin pi is 0 and 3 pi by 2. So this is decreasing from 0 to -1. And then it is increasing from -1 to 0 again. Alright. So make sure you understand this. Alright. Same way for cos. So cos is decreasing from 1 to 0 in the first quadrant. Again it is decreasing from 0 to -1 in the second quadrant. Third quadrant it is increasing from -1 to 0. And fourth it is increasing from 0 to 1. Alright. So just understand this. And once you understand for sine and cos, you can easily understand for tan, cot, remaining trigonometric ratios. Alright. Okay. Now allied angles. So when two angles are said to be allied angles when their sum or difference either 0 or multiple of pi by 2. Now very important topic. Okay, pay attention here. How the trigonometric function changes at their allied angle. So very important. Now remember one thing. Trigonometric function will change. Okay, when it is pi by 2 or multiple of pi by 2. Now what do I mean? So whenever the angle pi by 2, I can say 2n plus 1 pi by 2 form. Okay. So sine changes to cos or cos changes to sine, tan and cot, and sec cosec. Alright. So this will interchange. Now see, this is 0, this is pi by 2, pi and 3 pi by 2, this is 2 pi, or I can say 0, then 90 degree, then 180 degree, 270 degree and 360 degree, right? So we already know this. Now when I say minus theta is here. This is minus theta, correct? So now when I talk about sine, so sine minus theta is minus sin theta because it is in fourth quadrant. Alright. Then pi by 2 minus theta. So sign changes to cos. I just told you, right? When it is pi, a multiple of pi by 2 form. So pi by 2 minus theta. Now pi by 2 minus theta is in first quadrant. See, pi by 2. And then if theta is here. So this is nothing but pi by 2 minus theta. Okay? Understand? This is theta. This is pi by 2 minus theta. So this is in first quadrant. So sign changes to cos, and first quadrant all angles are positive. So it is just cos theta. Now pi by 2 plus theta. So it is here. Right? So it is in second quadrant. So sign changes to cos, and sign in second quadrant is positive. That's why this is positive. Now pi minus theta. This angle is pi minus theta. Okay, so this is again in second quadrant. In second quadrant sine is positive, so that remains same as sine theta. Now when I talk about this pi plus theta, so third quadrant pi plus theta. In third quadrant sine is negative, so sine remains as sine, but it is minus sine theta. Then this is 3 pi by 2 minus theta. Okay, so sine changes to cos. In third quadrant sine is negative, that's why this is negative sine, negative cos theta. 3 pi by 2 plus theta. This angle is 3 pi by 2 plus theta. Fourth quadrant, in fourth quadrant sine is negative, sine changes to cos, so this is negative cos theta. Alright, then 2 pi minus theta, this angle is 2 pi minus theta. Fourth quadrant sine is negative and sine remains sine, so this is minus sine theta. 2 pi plus theta first quadrant, so this angle again it is 2 pi plus theta and first quadrant, so this is positive. I hope you understand how do I did this, right? Same thing you can think for the remaining trigonometric ratios, and you can try this your own. If you get confused, pause the video, try to do it your own. Automatically you will understand what to do. Alright, let me know if you have any doubt. I'll surely reply in the comment box. Now here the value of sec x is given, okay, -2. Also this is very much important. Pi less than x less than 3 pi by 2. Now which quadrant it is? Yes, you are right. This is the third quadrant. Okay. First of all, we have to figure out which quadrant we are talking about. Now, based on that, remember ASTC rule, right? So remember this. Now, in third quadrant, tan and cot are positive. Other trigonometric ratios are negative. So, when we write the values, we have to put the negative sign for the remaining ratios. Alright. So, now it is easy. Cos x is what? -1/2. Correct? Then sin x. Sin x is what? Square root of 1 minus cos square x. And in third quadrant sign is negative, so I'll put the negative sign. And now I'll find my answer. So minus of 1 minus 1/2 square. So what do we get? If I'll put if I simplify this, I'll get minus √3 by 2. Correct? Same way, I can write cosec x value. This is nothing but minus 2/√3. Correct? Then I can write tan x value. Now tan x is what? Sin x over cos x. So I'll get positive value. Correct? So √3, and then cot x is nothing but 1/√3. The both are positive. I hope you understand this, right? So how have we decided the sign? Based on this quadrant. So this is given over here. Alright, perfect. Now see, very interesting question again. So here we have to prove this. So I'll take LHS is equals to 2 sine square pi by 6 plus cosec square 7 pi by 6 into cos square pi by 3. Alright, now pi by 6 is 30 degree. So sine pi by sine 30 degree, we know that. So this is nothing but 1 upon 2 square. Okay. Now cosec square. Now see, this is what I can write as 6 pi plus pi upon 6, right? And then cos square pi by 3. Now see, here 2 1/4 plus. Now when I individually break this, okay, 6 pi upon pi, I'll get just pi plus pi by 6, correct? Times cos square pi by 3. Now here 1 upon 2 plus. Now pi plus theta. This is pi plus theta form. So cosec remains cosec. Okay. Now cosec pi by 6. Pi by 6 is again 30 degree. So cosec 30 degree is 2. But this is in third quadrant. So I have to say this is minus 2. Very, very important. Okay. This is minus 2 square times cos 60 degrees 1 upon 2 square. So we'll get 1/2 plus 1, correct? And this is nothing but 3 upon 2. So this is RHS, correct? So very important. Do it carefully so that you can avoid all the mistakes. Practice this type of questions so that you can solve them very quickly and easily. Alright. Now here in this question, we are told that straight away the x is lying in the second quadrant. So again ASTC rule, second quadrant sine and cosec are positive. So the remaining ratios are negative. Now cot is this. So cot x equals to negative 5/12. So what I can say, tan x is negative 12/5, correct? Then I'll get the using sec square x equals to, sec is negative, so I can say minus of 1 plus tan square x. You have to show this, okay? So minus 1 plus minus 12 upon 5 square. When I simplify, minus, this is 25 plus 144 over 25, and on simplifying this we'll get 289. So I'll directly write this as 17 over 5. Okay. So we'll get this value of sec x. Sec x. Okay. This is sec x value. So I can write for cos x. Cos x is minus 5/17. Correct. And then I can write for sin x and cosec. So sin x is positive, so I can write this as 12/17, and cosec is 17/12. They both are positive in the second quadrant. So I hope you understand this clearly. Okay, perfect. Now for this type of question, okay, when the angles are in terms of degrees, so we have to try to write the angles in terms of multiple of pi. Means what? 0 or 180 or 360, or next is 540, correct? Then if I'll go further, 720 and so on, correct? So we have to try the nearest angle with this. So what I can say, I can write this as cos 540 minus 30, right? Degrees. Just mention these are degrees. Now cos 360 minus 30 again, correct? Then plus sine 360 plus 30 degree, and then cos, this is 180 minus 60 I can say, right? Okay, so we have to prove, so I have to write for LHS. So just copy this question and then solve this. Alright, okay. So now we have to decide. See, all are in multiple of this pi value, so cos remains cos. Now you have to simply understand which quadrant it is, right? So see, you can decide this as this. You already have this, correct? Now this is 0, this is 180, correct? This is 360, then 540, 720 and so on, right? So I'm talking about this. So 540 minus theta. So pi minus theta, second quadrant. Second quadrant cos is negative. Cos 30. So you'll get minus root 3 by 2. Okay. Then 360 minus 30 degree. So fourth quadrant. Cos is positive. And I can say again cos 30 degree. So minus positive. So root 3 over 2. I get this value. Then plus sine 360 plus 30. So first quadrant. First quadrant sine 30, I'll get 1 over 2, and cos 180 minus 60. 180 minus 60 again second quadrant. Cos is negative. So what do we get? Minus 1 over 2. So when I simplify this, I'll get minus 3 upon 4, then minus 1 over 4, and this gives me minus 1. So this is nothing but RHS. I hope you understand how to figure it out, right? Okay, practice this. Okay, now let's solve this similar question. Okay, so I'll write LHS sine minus 420 degree cos 390 degree plus cos minus 660 degree and sine 330 degree. Alright. Now sine minus theta. Remember this? Sine minus theta is equals to sine theta. And cos minus theta is, sorry, this is minus sine theta and this is cos theta. Okay. So this won't change. So I can write this as sine minus of sine 420 degree. Then cos 390 degree. Okay. Cos minus theta won't change. So this remains cos 660 degree and sine 330 degree. Now we have to use allied angles. So minus of sine. Now this is 360 plus 60. Then cos 360 degree plus 30 degree. Then plus cos 660. So I can use 720 minus 60 and sine 360 minus 30. Correct? Alright. Now this is first quadrant. So sine 60 is minus root 3 over 2 into cos 30 again root 3 over 2 I get, correct, plus 720 minus theta. So fourth quadrant, in fourth quadrant cos is positive and cos 60. So cos 60 will get 1 over 2, and here sin 30 will get minus 1 over 2, correct. So we have these values. Again the same way you get minus 3 over 4, minus 1 over 4, and the answer is minus 1. So this is your RHS. I hope you understand this now. Correct? Now here in this question, theta lies in third quadrant. This is third quadrant, right? So we can write the remaining ratios. So cos theta is minus 3 upon 5. Sec theta is minus 5 upon 3. Then sin theta is minus 4 upon 5. Cosec theta, you can show how you get that, okay? Minus 4 over 5 over 4 tan theta is nothing but now a positive. So 4 upon 3, and cot theta you get 3 upon 4. So we got all 6 ratios, and then I can evaluate this value. So cosec theta plus cot theta over sec theta minus tan theta. Now substitute their values. So minus 5 over 4 plus 3 over 4 over minus 5 over 3 and minus 4 over 3. So what do we get when we simplify? Negative 2 over 4, which is minus 1 half, upon minus 9 upon 3, which is minus 3. So you will get minus minus plus 1 upon 6. So my answer is 1 upon 6 for this. So be careful when you put these values and simplify this. Alright. Now this is the similar question. So I can write LHS is equals to sin 150 degree plus cos 120 degree, cos 330 degree, and sin 660 degree, right? And we can use a similar thing. So sin 180 minus, I can use 90 plus also, okay, if you want to, but you have to convert them, correct? So I am using this 180 minus 30 plus cos, sorry, this is into, so this is into, okay, just make sure you are not making this mistake. Cos 180 minus 60 plus cos 360 minus 30 and sin 720 minus 60, right? And now we have to simplify this. So this is in second quadrant. Second quadrant sign is positive. So sin 30, 1 over 2, cos in second quadrant negative. So minus 1 over 2. Again here cos 30 degree in fourth quadrant, which is positive. So root 3 upon 2 into sin 60 in fourth quadrant, which is negative. So root 3 upon 2 minus. So you will get minus 1 upon 4 minus 3 upon 4, which is minus 1, which is RHS. So almost similar questions, right? So practice this type of questions. Here these questions are easy, but topic is very complicated. So try to understand this. If you have any doubt, please let me know. And if you like this, please share with your friends. Thank you for watching.